Hello folks, today we're going to be going over the 35s, which is calculating voltages for redox reactions. I'm going to go through the front page with you and a problem, and then we'll go from there. So as it says here on the board, it says calculating the voltage of a redox reaction can tell you if a reaction will occur. Calculating a voltage can tell you if you can store a chemical in a container made out of another chemical. In other words, if you're building a battery, what could you make the outside out of? And then finally, we're going to calculate voltages to tell you what chemicals you can use to make batteries of different voltages. So the question that we have is, can you store hydrochloric acid in an aluminum container? So why don't you take a second, right? Yes or no, your choice. And we'll go through the process to find out. So here we go, we're going to go through the process. The first step is to assign oxidation numbers to all of the elements. So we've done this before. Nothing new there. And so we have hydrogen going from a 1 positive to a 0, so that is reduced. And that is gaining 1 electron. And we have aluminum going to aluminum ion, so that's oxidation, and that's losing or a loss of 3 electrons. So nothing that is new there. Now we're going to write the two half reactions. So this is what we've done before. So we have aluminum go to aluminum ions. We have this 3 positive charge. We've got to balance that out with 3 electrons. So we have 0 for a net charge on each side. Nothing new there. We get on to this bottom reaction. We have hydrogen ions going to H2. So we put a 2 out in front of the hydrogen ions to balance that. Now we have 2 positive charges there, so we add 2 electrons to this side to bring both sides to 0 there, and 0 on that side. Again, nothing new there. The electrons that are lost in the oxidation reaction have to be gained by the reduction reaction, so that's why we multiply this one by 3 and this one by 2 to get the electrons to be the same in each. The aluminums then are at 2, 6 hydrogen ions, 2 aluminum ions, and 3 hydrogen molecules. So now we're looking at our half reactions, and we have to figure out, is it this one that matches this diagram down here, or is it this one that matches this diagram? So take a look at the back of your periodic table and figure out which of the two half reactions matches up perfectly to the back of your periodic table. This one right here matches up perfectly with this one. So this is the reduction half reaction. Remember, these are reduction potentials. And so it matches up perfectly to this reaction, and we write down the voltage that goes along with that. So that is where this comes from, and we put a big V for voltage. We look at this one, and we go down here, and it looks similar, but it's the exact opposite what's on the reduction potential sheet. So in other words, we have to take this reaction, and we need to flip it. So you've got to flip the direction of it. And when we flip it, we also have to flip the sign that's in front of the voltage. So since this reaction is flipped, the voltage also has to be flipped. And so we're going to go from negative 1.66 volts, which is on your chart, right there, and we're going to go to positive 1.66 volts. So if we flip the reaction, we're also going to flip the charge that's in front of it. So negatives become positives, positives become negatives. So this is what we have so far. Again, we flip this voltage right there because we had to flip the reaction. Every time you do one of these problems, you will have to flip the oxidation reaction to get it to look like one of those. Or I should really be saying we have to flip one of these reductions to look like the oxidation that is in our problem. We add the voltages together, 1.66 volts. And it says add the two voltages of the half reactions, never multiply the voltages by any number. The mixture of chemicals can only give you a particular voltage. If the overall voltage is greater than 0 volts, the reaction will occur spontaneously. That means the reaction will occur. It doesn't mean the reaction is fast. So could you put hydrogen ions or an acid into an aluminum container? And the answer is no, because they would go through a redox reaction and that pail would fall apart after a period of time. When it comes to batteries, these two and these two, those four all have the exact same voltage. The only difference is the size of the battery, which means that they will last longer the bigger the battery. So this battery right here will last a lot longer than one of these batteries. They all have the same chemicals in them and the same metals in them, and therefore they give off the same voltage. This one right here, though, is a 9 volt, and that's going to have different chemicals in it and different metals in it to get you to a higher voltage. So here we go. Here's where we're going to teach you what's going on. So we have our reaction right here. We're going to treat it just like we always have. We're going to put oxidation numbers on top. There's 0, 2 positive, a 3 positive, and a 0. We do our brackets then. So this one is reduced. This one is reduced. Reduced, and that's a gain of 2 electrons. This one is oxidize, lose 3 electrons, and so that's where we are. Now down here we go Au, going over to Au 3 positive. We use your cover, we go through all the steps. Balance everything besides hydrogen and oxygen, done with that. Balance the hydrogens, did that. Balance the oxygens, did that. Those don't really apply. The last one is balance the charges by adding electrons to the more positive side. So add 3 electrons to this side. The reduction part is Pb2 positive going over to be lead. Again, go through all the steps, balance everything besides hydrogen and oxygen. Hydrogen and oxygens don't apply here, so you don't have to balance those. Balance the charges by adding electrons. So 2 electrons get added to this side. Now our electron values have to be the same, so I have to multiply the top one by 2. And I'm going to multiply this bottom one by 3 to get them to balance. And if we do that, we get 2Au, we get 3 Pb2 positive, the electrons cancel out, you get 2 gold ions, and you get 3 lead. Okay, and those numbers are going to go up here, 2, 3, 2, 3. Okay, so that's all that stuff is the exact same stuff that we have been doing before. But now we have to assign voltages. So one of these two reactions is going to be exactly as it is written on your sheet. And so we have this one is exactly on the back of your periodic table. So we take that voltage exactly. So it's negative 0.13 volts. And the gold, this one right here, is 180 degrees different than what we have written. So we have to flip it. And if we flip its charge. So we go from a positive 1.50, stated right there, and once we have to flip the reaction, it goes to negative 1.50. We add those two together, and we get negative 1.63 volts. So now we can go ahead and we can fill in everything in our table. So item oxidized would be gold. E of oxidation, negative 1.50 volts. Element that's reduced, Pb to positive. E sub 0, or the electricity that's going to be released from that, negative 0.13 volts. And our E total is negative 1.63 volts. It's not spontaneous because it is a number that is less than 1. Remember, when we get voltages greater than 0, they are spontaneous, and less than 0 are not spontaneous. So this one is definitely less than 0, so it is not spontaneous. Try the other problems, and I'll put up the answers in a little bit. So stop the video, try the next two problems. So this is a prettier version of what I just went over. The one thing that we do have to look at is this is a non-spontaneous reaction, which means you could safely put lead ions in a gold bucket. You could safely do that. In a second, I'm going to give you the answers to the next problem. You should pause the video and then check your answers against the next problem. So there are the answers to problem number 2. After you've checked your answers, you should pause the video, try number 3, and then check your answers against number 3. Here are the answers to number 3. Now the homework was the next page, front and back. That would be the 40s. That would be due for tomorrow. Need any help? Come on in.